Hello everyone and welcome to another video on our own devices. I'm Jin Messier, and as I've mentioned several times before, I will often come across items that, while fascinating in their own right and well worth presenting on this channel, don't quite warrant their own full-length videos. And in such cases, I will typically wait until I have 5 or so such items in order to produce a grab bag video. And I do this in order to provide you, the viewer, with more bang for your buck out of any given video. Today, however, I thought I might do something a little bit different and experiment with some shorter form content, which, if you enjoy it, will hopefully allow me to produce more content more regularly going forward. Anyway, the item we're going to be looking at today might seem familiar to long-term viewers. As I recall, about a year ago, I did a video on the number 2 developing and printing outfit, which was a basic darkroom kit produced by Kodak for amateur photographers in the late 1930s and early 1940s. And as you'll also recall, that particular kit was pretty bare bones, to the point that the darkroom safety light was simply a candle lantern with a red shade. And this is because that kit was produced during the Second World War, when a lot of Kodak's resources were tied up in supporting the war effort. And indeed, that kit included a little slip of paper that told the buyer, if you have difficulty finding Kodak products, hey, screw you, don't you know there's a war on? By contrast, this kit, the ABC Photolab outfit, was produced immediately after the war, starting in 1947. And the contrast in the quality of the materials between the two kits is night and day. So let's actually have a closer look at this, and you'll see exactly what I mean. Now, if you want a more detailed breakdown of how black and white photography and developing works, please check out my previous video on the number 2 developing outfit. But briefly, traditional black and white photo emulsion contains silver halide salts, which decompose into metallic silver crystals when exposed to light. And this produces a very faint pattern known as a latent image. Now, in order to develop this image, you have to place the film in a developer solution, which promotes the growth of those silver crystals, causing the latent image to become clearer and more high contrast. However, you have to time this carefully, because if you leave the film in the developer bath for too long, it will develop all of the unexposed silver halide crystals, and you just end up with a black photograph. Now, once the image has been sufficiently developed, you then place the film in a stop bath, which halts the action of the developer. And finally, you place it in a fixer, which dissolves away the unexposed silver halide, leaving the developed image behind. However, this is a negative image with the more exposed areas represented by black silver crystals. And so in order to produce a positive image, you then need to print the negative. You do this by sandwiching the negative against a piece of photosensitive paper, exposing it to light, and then developing the paper as you would the film. And this kit contains everything you need to carry out both those processes. So if we open up the box, you'll see that the whole kit is contained within an enameled metal box, which doubles as a contact photo printer, but we'll look at that in just a second. So if we lift up the lid, we'll see our contents. First, we have our instruction booklet, as well as some more detailed instructions on the TriChem developer packets contained within. We then have a set of 3 metal chemical trays. One is for the developer solution, one for the stop bath, and one for the fixer. Next, we have 2 boxes containing TriChem packets of developer chemicals, and these are designed to be mixed with water and poured into the chemical trays. So the developer is what is known as MQ, which is a mixture of metol and hydroquinone, and these 2 chemicals are packaged separately and designed to be mixed together with water. The stop bath consists of acetic acid, so basically highly concentrated white vinegar, but it also contains an indicator chemical to let you know when the acid has been used up and neutralized. And so this starts out a pale orange-yellow color and changes to dark purple as the acid is used up. Now, I haven't been able to find any literature stating exactly what this indicator is, but about the only pH indicator I was able to find that undergoes this specific color change over this specific range of pHs is bromocresol purple, which changes from yellow to purple from pH of 5.2 to 6.6, which is nearly neutral, meaning that the acid has been almost completely used up. And finally, our fixer is most likely sodium thiosulfate, also known as hypo, or more likely ammonium thiosulfate. And according to the instructions, each box of chemical packets contains enough developer to develop 2 full rolls of film or 40 photo prints. Now, in order to mix up these chemicals in the proper proportions, the kit comes with a specialized measuring cup, a glass stirring rod, and a thermometer. And the thermometer is to ensure that the chemicals are used at the proper temperature. If they're too cool, they will underdevelop the film. If they're too warm, they will overdevelop the film. And the proper temperature is marked on the thermometer by a little star symbol. And according to the instructions, to adjust the temperature of the chemical baths, you create a bath of warm or cool water and dip the trays into them, making sure that the bath doesn't actually spill over and dilute your developing chemicals. Next, we have a packet of photo printing paper, in this case, Kodak Villite paper, which was the basic entry-level photo paper. Kodak also produced other products, including Velox and Azo paper, which was produced in a number of different finishes, such as gloss and matte, and also in a number of different contrasts, 6 to be specific, labeled 0 to 5. And this was to create a better contrast print out of a negative that had been over or underexposed. So for example, if you had an underexposed negative that looked washed out and flat, you would use a higher contrast paper in order to increase the contrast. So say a 3, a 4, or a 5. Conversely, if you had an overexposed high contrast negative, you could then flatten it out by using a number 0, 1, or 2 piece of photo paper. Next, we have a pair of clips used for handling the film. You clip these to either end and use them as handles in order to run the film through the different chemical baths. And once you were done, you would hang up the film using the clips, with the weight of the clip stopping the film from curling and making it easier to produce prints. And finally, we have our darkroom safety lamp, specifically a Brownie darkroom lamp, which, unlike the wartime version, is actually fully electric. And this was designed to be hung from the ceiling of your darkroom. Now, one of you commented on my previous video on the number 2 development kit that you don't actually use a safety light when handling the film. You have to handle the film in pitch darkness, and you only use the safety lamp during the printing process to align your photo paper with the negative. But that's actually not quite true. You can use a safety light with older orthochromatic films. So orthochromatic film, which is the original type of photoemulsion from the dawn of photography, uses simple silver halide salts, which are most sensitive to the blue end of the spectrum. And this is why in very early photographs, the sky looks completely washed out and white, because the blue coming from the sky quickly overexposes the film. And because the film is completely insensitive to red light, anything red in the photograph shows up as black. And because the film is insensitive to red, you can use a red safety lamp while working with that film. However, in the 1910s, Kodak and other companies started coming out with panchromatic film, which used sensitizing dyes to make the silver halide sensitive to the full spectrum of colors. And so because this new film was now sensitive to red, this film you had to develop in pitch darkness. Now, in addition to being a darkroom safety lamp, this light can also be used in the printing process. So I mentioned at the beginning of the video that the box that this kit comes in doubles as a contact photo printer. And so how this works is you thread the lamp socket into the threaded hole on the side of the box, then thread in the lamp on the other side. And you'll notice that the inside of the box is painted white to more evenly diffuse the light. Now you could use 3 different types of lamps for this process according to the instructions, which were the number 1 photo flood lamp, the number 212 photo enlarger lamp, or a regular 100-watt frosted lamp, none of which were included as standard in this particular kit. And so in order to print a photograph, you would place the lid on top of the box, and then you would twist these latches on top and remove this panel, exposing a sheet of glass. And so you would place your negative on the glass, and then you would place your photo printing paper over top of it, If you wanted a white border, you would also place a mask in between the two, which could be cut from this convenient card that's marked with a grid pattern. You would then place the lid back on, secure the latches, and then you would turn on the lamp for the prescribed number of seconds, usually between 2 and 5 seconds. And the photo paper, unlike the film, could actually be handled without the use of a darkroom, provided that your light source was fairly subdued. And once the paper was exposed, you would then develop it as you would the film using your 3 chemical baths, and presto, you would have your finished print. So that's really all there is to this. Functionally speaking, this is identical to the earlier number 2 kit, but the quality of the materials is far and away superior. And so this presents an interesting microcosm of the contrast between wartime austerity and post-war prosperity. Anyway, that's all I have for you today. Thank you so much for watching, and I'll see you next time on another video where we'll look at yet more fascinating devices just like this. Please let me know if you like this shorter content, if you want me to make more shorts like this. I really appreciate your feedback. But until then, I'm Jean Messier from Our Own Devices. Have a great day.